Alcohols. Alcohols, they are a new class of homologous series. We can also name them as alkanols, or we simply say alcohols. So we can start from the naming, first of all. What difference we are observing in the name of this homologous series? As you can see, there is ending E of an alkane. If you look at the spellings of alkane, so ending E of an alkane, that is replaced by OL, that is alkanol or alcohols. Actually, it's a new homologous series, and in this homologous series, its functional group, that is OH, right? Okay, so all those compounds which have OH in their molecular formula, they are known as alcohols. Okay, look at their structure. For example, if I have one carbon and it is bonded with four hydrogen atoms, so it is a member of alkane series. We know the name of this compound, it's methane. So if I remove any one hydrogen of this methane and replace it with OH group, so it will become the member of this new series, which is known as alkanol. And now the name of this new compound will also be derived from the name of an alkane. Okay, I took this example, CH4, and I replaced one of the hydrogen with the OH group. So earlier, was the member of alkane series and its name was methane. Now, when I replaced one of the hydrogen with the OH, it became the member of this alkanol series. So, as I said, for their naming, what we will do, the ending E of an alkane replaced by OL. So, its name will be then from methane to methanol, ending E replaced by OL. Similarly, if I have this alkane CH3, and the name of this alkane, that is ethane, and any one hydrogen replaced by, I am replacing hydrogen and adding, positive sign means adding, or you can say substituting this OH group on these carbon atoms at any position. So it will be,
Ethanol.
yes, the ending E replaced by OL. So it will be ethanol. So now these are actually their structural formulas, or we can say displayed formulas. Their structural formulas will be CH3OH for methanol. And if I want to write down its structural formula, it will be CH3, CH2, and OH, that is ethanol. And when we show all the bonds, that is known as displayed formula, and its molecular formula. Okay, so we can derive their molecular formula from the molecular formula of an alkane. So if we look into the general formula of an alkane, that was CnH2n plus 2. For making alcohols, what we are doing, we are replacing one hydrogen. So that will be CnH2n plus 1. We reduced one hydrogen, removed one hydrogen. So 2n plus 2 became 2n plus 1. And in the position of that hydrogen, we added OH. So it will be OH. So the general formula of alcohol will be CnH2n plus 1 OH, as we can see here. So if I want to write down the general formula of this ethanol, so I can say there are two hydrogens. So carbons, how many hydrogens will be there? 2 into 2, 4 plus 1, 5, C2H5, and then OH. So we can see here two carbon atoms, 1, 2, 3, 4, and 5 hydrogens, and then OH. And sometimes we also write it like the C2H6O. Even more simplified form, there is simplest ratio between the carbon and the hydrogen and the oxygen. That's not the simplest ratio, but we can say it is, showing the ratio between these elements, 2 carbons, 6 hydrogen, and 1 oxygen. Is it clear? So C2H5, so general formula of alcohols is also derived from the general formula of an alkane. And now after this, let's try to name some of the alcohols. Look at this. When we have one carbon and there is OH group, then its name is derived from meth to methanol. If there is two carbon atoms, then ethanol. If three, then propanol, right? And if we have four carbon atoms, then it is butanol. Okay, here we have one more thing very important. In these compounds, actually, we focus on which thing? We focus on the longest chain of carbon atoms. And we number this longest chain from the end where OH group is nearest. So it is on the right side. So I will number the carbon atoms 1, 2, and carbon 3. So here OH group is attached on the carbon 1. So it will be 1 propanol, right? But same 3 carbon atom molecule, but I can replace the hydrogen of this central carbon. And you can see here now the OH group is on the carbon 2. That is my longest chain of carbon atom. Now its name will be 2-propanol, right? So these two are different compounds, and these two are isomers of each other. Okay, which type of isomers? Previously, we have discussed the two types of isomers. Number one, chain isomers, in which they were different in terms of their chain structure. And now they are different in terms of the position of the functional group. Here, the position of the functional group is 1. Here, the position of the functional group is 2. So these are two isomers of each other, and we can call them position isomers. Is it clear? So they can also be named as propen to ol. The ending E is replaced by the position and the ol. Ol actually represents the alcohol functional group, OH functional group. So if it is propen to ol, so this will be propen 1 ol. So let's try this name, this one. Simply we can call it butanol. But if we talk about specifically the position of this functional group, it is on carbon 1, right? You can see here. So its name will be butan one ol. Why? Because the OH group is on carbon 1. Now let's draw the isomer of this butane 1-ol. I am now placing the functional group on carbon 2. So here you can see the longest chain. I'm not showing the hydrogen atoms for simplicity. So OH is on carbon 2. So its name will be butane 2-ol. Now you can see they are isomers of each other. And what's the difference? Difference is in the position of their functional group. So we have seen this position isomerism in alcohols, and we have seen that position isomerism in alkenes. Remember the position of the double bond like this, or position of the double bond here, right? So one butene and two butene in the previous alkenes topic. Now, after the naming of these alcohols, let's talk about their preparation. How can we prepare these alcohols? And in our syllabus, we are actually focused on the preparation of ethanol. And we know the molecular formula C2H5 and OH. That is ethanol, two carbon atoms. So there are two ways, very famous. One of them we have earlier done in the previous topic, the chemical properties of alkenes. We know that when ethene, I'm drawing the structure of ethene like this. If we treat the ethene with water in presence of phosphoric acid. So we know that one of the double bond that will break and water will add on these carbon atoms. So the hydrogen goes to one carbon and the OH goes to the another carbon. So if we look at their structure, it will be, earlier it was CH2, now it will become CH3. And single bond remained. Then earlier it was CH2, now it will be CH2 and then OH. And we also heated this reaction. So remember, the conditions are very important in the presence of an acid. When ethene reacts with steam. Why I'm using the word steam? Because at high temperature, this reaction is occurring. So ethene on reaction with steam, or you can say the addition of steam to ethene, that gives us ethanol, right? Now, this is basically a process by which we can prepare ethanol on industrial scale. So in industry, we can prepare ethanol. And you know that ethanol is one of the very famous fuels. So there is a higher demand of ethanol in the market. So in industry, we can prepare ethanol. And what are the advantages and disadvantages of this method? So as we can see, one of the advantage that the large amount, or you can say continuous supply of ethanol is possible by that method. So continuous supply or preparation can be done by this method, right? Okay. There is another very useful benefit of this method, that the ethanol which is produced by this method, there is only one product. So no need of purification or separation from the waste products, right? no need of purification. So it is the only product. So very important use of you can say benefit of this method. So no need of purification, so only one product. And there are some disadvantages as well. So what is the disadvantage? Look at that. Hmm. So whenever we talk about the disadvantage, we can see here the raw material, ethene. So ethene is basically a raw material which is taken from the petroleum. So ethene is taken from crude oil. And we know that crude oil is not a renewable resource. And as we are using it in a huge quantity, so that it is going to end in the world. So ethene is taken from crude oil, which is not renewable resource. So it can end at some time. Clear? And also in industry, you can see it is a costly. Cost is also another disadvantage of this method. So continuous production of alcohol is possible by this. No need of purification. These are the advantages, but there are some disadvantages as well. You can see not a renewable resource. Now let's see the another method by which we can prepare ethanol. Second method, that is from glucose. Okay. The formula of glucose C6H12O6. So, and the main source of glucose, that is plants, right? So either in the form of starch or cellulose, we know their hydrolysis, they give us glucose. So if we use the glucose C6H12O6, and when this undergoes fermentation from glucose by fermentation. What is actually fermentation? Now, we know that fermentation, that is basically a reaction which takes place in the presence of enzymes, right? And these enzymes, they are produced by the microorganisms, right? So it's a biochemical process. Why? Why I'm using the word bio? Because the microorganisms, these are living organisms which produce these enzymes. And yeast is that microorganism which produces enzymes. And these enzymes, they convert this glucose into ethanol. And along with this, carbon dioxide gas is produced. But here, when we perform this, remember, this reaction takes place in absence of oxygen. Clear? So in a closed container, this reaction can take place, which is known as fermentation. And there are some conditions which are very important. Number one, absence of oxygen. Number two, the pH must be controlled around 7.35, not more than that or less than that, or specific temperature, which is around 37 degrees Celsius. So if the temperature goes beyond this temperature or less than that, so the yeast that will become inactive. So these conditions are also very important. It means that this reaction can take place in a controlled conditions. So remember the conditions: absence of oxygen, the pH, specific pH, and the temperature. So if these conditions alter, the reaction will stop. And now there is one very important thing, that when this reaction takes place, if the percentage of the reaction mixture, when it reaches to 14%, if the percentage of this ethanol go beyond this 14%, then enzymes they become inactive. So we can say that is another limitation of this reaction, right? So we can get ethanol maximum of 14% in this reaction. Then we have to stop it and we have to distill this ethanol from the raw material. So it means distillation is also very important. We have to separate this ethanol from the reaction mixture. So these two are actually the disadvantages. We can say these are disadvantages of this reaction, isn't it? That the maximum percentage of ethanol can be only 14%. We have to distill this ethanol from the reaction mixture, and we also have to control all these conditions. And also, it is not a continuous process, it is a batch process, right? Another disadvantage of this reaction, if it is a batch process, we have to add ethanol and water, glucose and water and enzymes along with it. And then we have to wait for some time. So that means it is a slow process. While this method, which we were using in industry, that was a fast process and continuous, right? So this is a batch process and it is a slow process. So all these are disadvantages, but there are some advantages as well. You can see it is prepared from glucose and glucose is taken from the plants. So it's a raw material, right? Raw material is renewable. So if the glucose is consumed on combustion, that will again produce carbon dioxide. Carbon dioxide is taken by the plants, and then plants convert that carbon dioxide into the glucose by photosynthesis process. So it means that reaction keep on going, and it's a cyclic process. So if renewable resource, it is not going to end. So that means that ethanol is better choice than simple gasoline, which is octane taken from the petroleum. So these are the two main methods by which we can prepare. Number one, that was from ethene. We can prepare ethanol in industry. Remember the conditions and the temperature that is around 350 degree Celsius, right? And this method, second, that is fermentation. Remember the conditions, the disadvantages, and the advantage of this fermentation process. Now, after this, let's look at their reactions. As we know that alcohols, they have, let's talk about their reactions. One of the very famous reaction which we do in case of alkane, in case of alkenes, that was a combustion reaction. That is same for all type of compounds, organic compounds, that if ethanol burn in presence of oxygen, it will give us carbon dioxide and water and heat as well. So that means it is a source of energy. It is an exothermic process, right? And the second very important reaction of these alcohols, so that is oxidation. What is actually oxidation? So oxidation is that process in which we can say taken oxygen, addition of oxygen, the removal of hydrogen, the removal of electron or increase in oxidation state. So when we talk about the oxidation reaction of these alcohols, so on reaction with oxidizing agent. So remember which oxidizing agent we are going to use. We are going to use acidified KMNO4, very famous oxidizing agent. And the color of this oxidizing agent, that is purple. So when we treat it, I'm writing this square bracket and oxygen that actually indicates oxidizing agent, or you can say it shows the oxidation, easiest way to represent the oxidation of an alcohol, right? So instead of writing KMNO4 formula, then sulfuric acid formula, that's a short and easiest way to represent the oxidation. So C2H5OH ethanol on oxidation, that will give us ethanoic acid. So it was ethanol, and a new class of compound is formed that is known as carboxylic acid. So one of the member as named ethanol, so it is ethanoic acid. Is it clear? Now, there is another reaction of this alcohols, that is reaction with carboxylic acid and forming an ester, but we will do that reaction after going through these carboxylic acids. And now next, their physical properties. Remember their intermolecular forces. Physical properties means melting point, boiling point, their density, everything. So when we talk about their physical properties, so remember their intermolecular forces are strong. Intermolecular forces are strong due to hydrogen bonding, right? That is very important. Why they have hydrogen bonding? Because they have OH group. Due to OH functional group. Clear? So if they have strong intermolecular forces, so definitely they will have higher melting point and boiling point. And they also have solubility. They are partially soluble in water. Why? Because they can make intermolecular forces with water as well. So due to this, they have another very important use because of their these properties. They are used in perfumes, right? They can be used as solvents even. Just like water, they can also be used as solvents. Clear? And they are also have a volatile nature. What is the meaning of this volatile nature? So they are volatile, that means which evaporate quickly at room temperature. Is it clear? So why? Because of their boiling point near the room temperature. That's why they are volatile. They can evaporate quickly at room temperature. So These are the basic physical properties and their uses of this ethanol, and we have discussed their chemical properties. One of them, that is combustion. Second, very important, that is oxidation. So can we use this one as a test for alcohols? Yes, you can see, if we want to ensure whether the given compound is ethanol or not, if we add acidified KMnO4, so on reaction, the purple color of KMnO4 will disappear. That gives indication that the given compound, that is ethanol, positive test for ethanol. And the most important, there is their production, their advantages and disadvantages. One on industrial scale from ethene, another one by fermentation. Clear? And what are actually ethanols? Ethanols are all those compounds which have OH group in them, and their name derived from the naming of an alkane.